Hello and welcome to Accounting Instruction Help and How To. In this lecture we're going to be talking about elasticity. At the end of this we will be able to define price elasticity of demand and explain what it means for demand to be either elastic or inelastic, calculate the price elasticity of demand, explain how elasticity affects total revenue as price changes, and define price elasticity for supply, explain what it means for supply to be elastic or inelastic, and calculate the price elasticity of supply. So elasticity is going to be one of those big concepts within economics that's going to be applicable to a lot of different areas. So a lot of different economic arguments are going to apply the principle of elasticity. So it's going to be something that we want to understand. So there's, for example, a couple topics that include the idea of elasticity in them. When we think about these topics, we'll include: should there be a tax on, for example, alcohol and cigarettes? Should we have an increased tax on alcohol and cigarettes? Making the idea being that an increased tax will reduce alcohol and cigarette consumption and make the country more healthy. Should we have a prohibition on certain things like drugs and alcohol? Those type of arguments. These are type of arguments on both sides of the arguments that can be looked through from an economic angle. That economic angle including arguments with regard to elasticity. So we want to be able to look through that angle. It's not the only angle to look at these arguments through, but it's a one big angle to look at it through, and a lot of arguments you'll hear in topics like these and a lot of other ones will include this type of argument, so it's good to look through. First off, what is elasticity? So we know that we have our downward sloping demand curve. What does that mean? Well, we have our graph. Remember that price is on the vertical axis. We got from the bottom to the top as prices go up from bottom to top on the Y or vertical axis, and we got the quantity going from left to right on the horizontal or X axis. So that's going from left to right, quantity's going up. If we imagine then our demand curve on this graph, it is sloping downwards. What does that mean? That means that as price goes up, we demand less quantity. As price goes up, quantity demanded goes down. As price goes down, quantity demanded then goes up. So that seems a pretty intuitive concept. If we were to purchase something that we like and the price goes up, then we probably going to purchase less of it. We're going to get substitutes. We're going to purchase something else in its place. If on the other hand the price goes down, then we'll probably pick up more of that. That's going to be the basic idea of the demand curve. Question now in terms of elasticity is, how much does quantity change with a change to price? Meaning if we change price a little bit and quantity changes a lot, then we're going to say that something's going to be more elastic. If we change price a lot and quantity doesn't change much, it's going to be less elastic. Elastic being similar to, you can think of a rubber band. So if we think of the rubber band and we say if we put a little force on the rubber band and the rubber band stretches a lot with a little force, we're going to say, well, that's a very stretchy and elastic rubber band. On the other hand, if we put a lot of pressure on the rubber band in order to stretch the rubber band out, and it doesn't stretch that much, we're going to say, well, that's not a very stretchy, or it is an inelastic rubber band. Same concept in terms of the reaction of quantity to a change in price. Price being like the force in this case. We're applying force to quantity by changing the price. So if we change the price a little bit and the quantity changes a lot, we're going to say, well, that's really flexible quantity in a small change to the price. That's going to be an elastic. And if we change the price a lot, we put a lot of force into the price, and the quantity only changes a little bit, then we're going to say that's going to be inelastic. So remember that the demand curve is downward sloping. So what that means that is, if we're talking about more of a horizontal demand curve, then it's going to be the more horizontal the demand curve is, the more flat line it is straight across from left to right, that's going to be the more elastic it is. Why? Because if the price, if we graph it, is on the vertical axis, and if we change the price just a little bit, if the price goes up just a little bit, then the quantity, if the line is going to be horizontal, will actually change a lot. And if that's the case, then it's going to be more elastic, meaning we're going to have a big change in terms of the change in price. If we think about it, something that's going to be inelastic, the more horizontal, the more vertical the line is, the more straight up and down the line is, then that's going to be more inelastic. So if you think about a downward sloping demand curve that's very up and down, very vertical, then a change in price, we can have a fairly large change in price, and you can graph it down to the quantity, and you can have a small change in quantity. So a big change in price, small change in quantity, that's going to be inelastic. So in terms of just visualizing the demand curve, you can visualize a demand curve and compare it to another demand curve, And the one that's going to be more flat is going to be more elastic, more susceptible to changes in price in terms of the change in quantity is going to be larger with the same change in price if the demand curve is going to be more flat. So we can think about it intuitively. We can think about elasticity intuitively in this way, thinking, well, we know that obviously if things change a lot, then if price changes and quantity changes a lot, it's going to be more elastic. We are going to talk about it in terms of formulas as well as actually calculating elasticity in terms of formulas. If we get back to our example here and say, well, how does this apply to some of the topics that we'll talk about in terms of politics and policies? Well, if we think about this idea of smoking, and the idea being that, well, if we increase the tax specifically on smoking and alcohol, that will reduce smoking and alcohol consumption, and therefore it'll make the country more healthy. Now, there's a lot of other arguments that aren't really economic arguments in terms of, should the government do that? Does the government have the right to influence people's behavior by putting in policies like that? Is it the government's job to put in those types of policies in order to influence that type of behavior, or not? Those are arguments and good arguments. That's another lens to look through. It's a very valid way to look at it. We just want to look here in terms of economics. Does it do what it says it's going to do? If the goal of the law is to reduce smoking and alcohol consumption, does it achieve that goal? And if you look at it through an economic lens in terms of that question, people come up with different arguments in terms of an economic argument, but a lot of it has to do with this terms of elasticity, and it's good to understand these terms so you can understand this kind of lens that people can look through and make these arguments about in terms of the effectiveness of a law such as this. So, for example, some would argue that it would be not as effective as you would originally think, because the idea of the elasticity would be that, okay, if we know the demand curve is downward sloping, and we know that if we increase price, we raise taxes, that in effect increases the price to the consumer, and therefore consumers will then consume less, because we know that if prices increase, people demand less. That's going to be the basic argument, and that's true. The question in terms of elasticity, however, is how much less will people consume? And there's different arguments here. If we're talking about someone who is addicted to a substance, just like we talked about with a drug example, then we would assume that the elasticity would be fairly vertical, meaning that people would be not as susceptible to change in quantity as a relation to a change in price. The price could go up, and if people are still addicted to it, then they would be willing to pay the higher price, and therefore the decrease might not be as much as originally thought of for that. There's also arguments in terms of who is actually being affected by the higher tax. And if you look at who is mostly smoking, who's mostly addicted to cigarettes, it's mostly lower income individuals. And therefore, if we increase the tax on cigarettes, it's quite possible that we have what we call a regressive tax, meaning we're actually taxing lower income individuals. And normally, from a progressive standpoint, we would want to raise the taxes on upper income individuals rather than lower income individuals. So that's one argument on it. Now, we could take it on a different lens on this. On the other side of the argument, using the same kind of principles, we can say that, well, those are the people that are already addicted. And it's true that if we're already addicted, we're less likely to have a substitute for cigarettes. It's not like, well, we increased the price of cigarettes, so I'm going to substitute for something else. Maybe I'll just go buy gum. Probably not going to happen because we're addicted to nicotine, right? It's not going to happen. But if you talk about the people that are entering the market, young people going into the cigarette market, then the effects could be different. There could be an argument that we would say, well, these people aren't addicted to cigarettes yet, and they do have an option. They can say, well, if you increase the price of cigarettes, maybe I don't have that much of a budget, maybe I will go buy gum, because to me, if we're a young person going into the market and we're not addicted to cigarettes, it's quite possible that we would say that I do have substitutes. I can buy cigarettes or I can buy gum, and they have the same outcome to me there. So possibly the increase in the price does have an impact possibly on the younger generation for that reason. Maybe the younger generation has a more elastic demand for that reason. They're not yet addicted, and so possibly from a prevention standpoint, the higher tax could be applicable there. So those are types of arguments, and again, it doesn't completely answer the question there, but those are types of the lenses that we want to look through and see what's the effect, how will people actually behave if we implement these laws. Same type of argument would go into ideas of prohibition. Should we prohibit certain drugs, or should we increase enforcement on certain drugs and or alcohol? We've had alcohol prohibition in the past, and again, you'll hear arguments on both sides of this. some being economic arguments, some not being economic arguments. But the economic arguments, how will people behave to a prohibition? And one of the arguments in terms of prohibition would be that what does prohibition do? It raises the price by increasing barriers to entry. So if people are still willing to enter that market in terms of a black market, then they're going to have a higher price in order to enter the market, and they'll probably be able to charge a higher price. The question is, how elastic is the demand then in terms of the consumer? Are they willing to pay that higher price? And if the argument is that the demand is fairly inelastic, meaning people are still willing to pay a higher price for drugs and alcohol, then if we limit the supply and we have a few suppliers, what does that do to the revenue of those few suppliers? It actually increases the revenue of those few suppliers, which means it draws, people into that type of market. And what does that do? Possibly that could lead to more increase in basically bad outcomes like violence and whatnot, because we're actually increasing revenue to the small group of people that are entering the market, and demand isn't going down. There's still demand at the higher prices. So that's going to be one of the arguments in terms of what's the outcome when we have things like prohibition. Does it cause more or less violence? And part of the economic argument has to do with, well, how elastic is the demand for these goods. What makes something elastic or inelastic? The main thing is going to be substitute. So if we can substitute for something, then it's going to be more susceptible to price changes, and the quantity will change more. So for example, if we're talking about donuts, and we can substitute a lot of things for donuts. We can buy Danishes, we can buy like Twinkies, we can buy a lot of different type of things, and therefore the price of donuts is going to be very elastic, meaning it's going to be very susceptible to other changes, because we can purchase other things for it. We can substitute a lot of different things. And the classic example of things that do not have a lot of substitutes, again, is like a drug. If we have a cure for cancer or something like that, and that's the only cure out there, that's the only drug that can cure cancer, well, it's not like someone that's buying the drug is going to say, well, I'm just going to go without it, or I'm just going to buy something else. I'll not buy the drug, I'll buy Tic Tacs. There's no substitute for it. So they're going to be willing to pay a higher price. Therefore, it's going to be inelastic. We apply these things to the workforce too. If we think about why do some people have higher paying jobs and other paying jobs, and if we think about the extremes, who gets paid a lot of times we think about sports athletes and musicians and actors and actresses and that kind of thing. Oftentimes, if we look at the top of those areas, we're talking about talent that's very high talent, that's been very honed very well, and nobody else has that. So I mean, that's why there's no substitute really for that top level tier of talent. Therefore, the pay is often quite high in those types of areas. In areas that there's a lot of substitution, there's a lot of other skill levels for it. If we're talking about working in fast food and whatnot, then of course there's a lot of other substitutes in that area, and that drives down the price in those types of areas. Another thing that'll account for the elasticity is how big of a piece of the budget it is for individuals. So for example, if we're talking about large ticket items, we're talking about like a car or something like that, then it's going to be more elastic, because a small change in the price of the car is going to be a big change in the price of our budget. Therefore, we're gonna be able to shop around a lot. We're gonna look into that a lot, and it's gonna be a long-term purchase. Therefore, the price is gonna be more elastic. If we're talking about something that's a very small piece of our budget, if we're talking about like a year's supply of paper clips, if they could double the price of paper clips, we may not even notice, because it's a small purchase. We're just gonna say, well, we need paper clips, and that's what they cost. It's pretty small compared to our budget. We're probably not really comparing what we paid last year or this year for our yearly supply of paper clips. So we'll probably just going to purchase that. So if it's a small piece of our budget, then the price goes up, it's more inelastic, because we're probably just going to purchase it anyways. If it's a large piece of our budget, then it's more elastic. We're going to look into it more. Another interesting aspect of elasticity is just the classification has an effect. So for example, if we're talking a broader classification of things, we're going to say it's more inelastic, less susceptible to changes in price. Quantity changes less in terms of price. And if we're talking about smaller areas, it's going to be more elastic. For example, if we're talking about like soda or pop or Coke or whatever we call it wherever we're at in the country, so soda pop, then if we're talking about that broad category, we're going to say that broad category is more inelastic than one type of soda pop like Coca-Cola. we're talking about Coca-Cola in general, if they change their price much, then people will probably go somewhere else at some point in time, and therefore it's going to be inelastic. Coca-Cola can't really change the price too much on their individual beverages. On the other hand, soda pop as a whole, if soda pop as a whole went up or down, it's going to be more inelastic. There's not as many substitutes for something like that's just soda pop as a whole. And we can take that to a bigger degree too. Soda pop is a subcategory of drinks in general. Anything that has water in it that we drink, then we could say that that's going to be a larger category. If drinks as a whole, the price of drinks, anything that has water that goes up, well, we're still going to need that. We're still going to buy it. It's going to be more inelastic. If soda pop as the subcategory of drinks goes up, it's going to be more elastic as in comparison to the entire category. Just a couple more examples. If we think about oil. Oil is a common topic of discussion, and that of course affects gasoline prices. If the price of oil goes up, and that increases the price of gasoline, in the short run, we're not going to make any changes. We're not really going to drive. We still got to drive to work. We still got to do what we got to do. Not a lot of changes in terms of our behavior for a change in gasoline. But in the long run, there's going to be more of a change. So in the short run, it's going to be inelastic. We can't substitute gasoline for something else to put in the car. But in the long run, it might be more elastic because, and we've seen this in the country, when the prices are going to be high for a long period of time, people do respond to it for after a long period of time. They start to buy smaller cars, and they start to have less of a commute, start to live closer to work, and this type of thing. If the price for gasoline goes down for an extended period of time, people do respond to it after a long period of time. They start to move to the suburbs. They're willing to drive further to work. They're happier to have a longer commute. They're probably driving. They can drive a big automobiles to and from areas. They're more willing to do that. And again, this affects some public policy, whichever side of the argument you're on. But it's going to be an effect. Some people actually think that we should tax basically fuel consumption and whatnot in order to influence people in the long run to do these things in order to reduce consumption. Others think that that's going to be harmful to many individuals and whatnot, and that economic argument is something to be aware of. If we're talking about like coffee or something like that, even specific coffee, there's a lot of substitutes for coffee. So coffee is usually going to be more elastic, meaning we can't really increase the price of coffee even if it's a good brand of coffee. And then again, the classic example, something like medical drugs. If it's something that you just can't substitute, it's going to be inelastic. The price is not going to have too much of an effect on the quantity. All right, so now we've talked about it intuitively, and intuitively I think this makes a lot of sense. Intuitively we're just saying, okay, how much does quantity actually change if you change price? Does it change a lot or does it change a little? Now let's think about it formulaically. So we want to think about this formulaically. How can we calculate this? So the formula is going to be elasticity equals the change in quantity over the original quantity divided by the change in price over the original price. So we're talking about the percent change in quantity is another way to say it, and the percent change in price. So when you're imagining that downward sloping demand curve, you're probably thinking, well, it should be the slope. And we're not talking exactly the slope. We're talking about the percentage change over the percentage change. Percentage change in quantity divided by the percentage change in price. Also note that because it's downward sloping, this will always result in a negative number. And the negative means nothing in this context. So we're always going to take the absolute value of it. So you can put absolute value lines on it, but just remember that we're just taking the number. We're not going to put a negative in front of it. It's always negative. We know that. We're not going to be dealing with a negative. We basically just remove the negative. So how do we calculate the percentage change? Well, if we're thinking about quantity, the way we calculate it is we're going to say, well, if we had quantity this year of 100 and then the next time period we had 150, the change then is 50. It went from 100 to 150. And then we're going to take that change, that 50, and divide by the original number, the 100, to get the change being a 50% change in that case. And if we talk about the price, same idea. The price, if the price was 100 and it went to 150, the change then would be 50 divided by the original number, and that's how we're going to calculate that. Now, just to point out, there's a couple, we could also use a midpoint formula, and this would be a bit more complex of a formula. So rather than just having the change, we can use a midpoint formula. Now, the reasons for this is that using our elasticity formula as we defined it, percentage change in quantity divided by percentage change in price, we actually have a difference in terms of we have a straight downward sloping demand curve. We will actually have a different elasticity at different points on the demand curve for this case. And if we want something that's going to be more consistent, we're going to use a midpoint formula. So I just want to point this out, and then we're going to go and we're going to look at an example using the original formula here. So it depends on what you're looking at in terms of which formula they're gonna put into play. But let me give you kind of an example of why this might happen. So let's say that revenue was $100 now, and we said there was a 50% increase. Then we would increase it by 50%. 100 times 50 by 150 times 50% increase would be 150. And then if we said, okay, now let's say there's a 50% decrease. So if we're starting at 150, 50% decrease, 150 times 0.5, that goes down to 75. It doesn't go back down to that original 100. So, I mean, you would think intuitively if we started at 100 and we went up 50% increase, we would go up to 150 and down 150, a 50% decrease. You would think we would go back to the original starting point, and we don't. And if we take this original calculation, and the reason is because the base number is changing. So if we wanted to account for that, if we wanted to say, okay, we want to be able to go up and down and have the same basically effect, then we can use this midpoint formula. So the midpoint formula, all we're going to do is we're going to take that same change in quantity, but instead of dividing by the original number, so our example was 100, it went to 150. So taking that 50 instead of dividing by the original 100, we're going to divide by the average of the 2 points. So the average of the 2 points would be the 100, and then went to 150. 100 plus 150 divided by 2 would be 125. So now we're averaging in order to basically smooth this process out. So the midpoint formula would be the change in quantity divided by the average quantity between the 2 points, divided by the change in price divided by the average price, the change in those 2 points. So I just want to point that out, so because that could be a point of confusion. We're going to basically use the original calculation as we go through this, as we graph it out, but just be aware that there's this midpoint calculation, and it just really depends on what you're looking at in terms of which formula you're going to be using. All right, so in terms of how do we determine what is elastic and what is inelastic in terms of a formula? So if we do our calculation, if we do our elasticity calculation, and we come up with a number that is less than 1, then we're going to say it's inelastic. So if it's less than 1, it doesn't change much quantity doesn't change much in terms of a change in price. If we come up with a number that is greater than 1, and again, we're removing they're all going to be negative. The absolute value, we can say the absolute value is less than 1, it's going to be inelastic. The absolute value is greater than 1, we're going to say it is elastic. And of course, if it equals 1, in the rare case that it equals 1, then it's unit elastic. So those are going to be our definitions. So when we actually do the elasticity calculation, it's going to be greater or less than 1, and that'll be what determines the elasticity. For example, let's say we have a good that we have the old price is $100. We took the price down to $97, and so we're going to calculate the percentage change. So if it was $100 and it went down to $97, we have a change of $3. So we're going to take that change, $3 divided by the old price. And we're not using the midpoint formula. We're using just the standard formula for the rate change. And so we're going to take the $3 divided by 100. There's a 3% change in that case. It's a decrease, but we're not going to put a negative sign in here because the negative sign doesn't really impact our calculation. We're always going to come up with a negative number. We're just going to basically use the absolute value. Okay, what happens to the quantity then? If after that decrease, if it went from 100 to 97 in terms of price, what happens to quantity? We're going to say it goes from 200 to 202. So we had a 2 unit increase for that $3 decrease in price. So if we take that $2 divided by the original number, the 100, we come up with a 1% percentage change. So we've got a change in price, 3%, a change in quantity, 1% in terms of percentages. We take the percentage change in quantity divided by the percentage change in price. That's our calculation for elasticity. We come up with 0.33, and that is less than 1. Therefore, it's inelastic. So that's how we're going to calculate that. It's important to note that when we're looking at a straight line downward sloping demand curve, so we have our demand curve straight line downward sloping, that if we use this formula here, then we're going to have different elasticities as we calculate at different points along that downward sloping demand curve. So as we get to the top of the curve, meaning we're close to the y-axis, close to the vertical axis, close to the price axis in this case, when we do the calculation for elasticity, we come up with a number that is greater than 1 in that region, meaning it's going to be more elastic. And as we move close, very close to the x-axis or the quantity axis, the horizontal axis down towards the bottom of our downward sloping line, elasticity actually becomes less than 1 when we do our calculation at points at that area on the downward sloping curve, and therefore it's inelastic. So we actually have a change from elastic to inelastic as we move down our downward sloping demand curve. There is a relationship between elasticity and revenue. So if we think about revenue in terms of our downward sloping demand curve, we have price and we have quantity. How do we calculate revenue? Well, we say it's the price times the quantity. The quantity that we sell times the price would calculate the revenue. So if we look at a particular point on the demand curve, we say here's our downward sloping demand curve. We pick a point on it, and let's say the point on it has a price on the vertical axis of 4. So we have a price of 4, and we're saying the quantity on the horizontal axis is 8, meaning it has a height of 4 and a width of 8 on either side, of course. So the area would be 4 times 8 or 32. So the area that we then could graph would then be the calculation of revenue, being the price times the quantity. So if we think about that calculation then, if you think about the calculation of revenue and we compare that to the concept of elasticity, revenue equals price times quantity. So revenue equals price times quantity. What if price goes up a lot and revenue doesn't go down, and quantity doesn't go down that much? That's going to be inelastic. Price goes up a lot, quantity doesn't go down that much. Well, if price goes up a lot and it's on the right side of the equal sign and quantity doesn't go down at a proportion, then what's going to happen to revenue? It's going to go up. So if we're talking about something that's inelastic, as we increase price, revenue will go up. And the opposite is true if we say that revenue equals price times quantity. And if we have a change in price that's a little bit, but the quantity goes down a lot, meaning it's going to be an inelastic good, meaning price goes up a little bit and quantity decreases a lot. Well, what's going to happen to revenue? Well, if the right side, price goes up a little bit, but quantity goes down a lot, revenue is going to decrease. So if we're talking about something that's inelastic under that reasoning, revenue would go down as price goes up. So let's just take a look at an example of this. If we have a downward sloping demand curve and we have a point on that demand curve and we're saying at a price of $200, we can sell 500 units. So $200, 500 units, if we multiply that out, we got price times quantity, we come up with $100,000 there. If, let's say, we increase the price from 200 to 400, now we're at 400, and we say that the quantity then changes from 500 units down to 400 units. So now we've got a price of 400, and we're selling 400 units. 400 times 400 is 160,000. In this case, we had something that is inelastic. What happened when we raised prices? It increased revenue from 100,000 to 160,000. If we're thinking about our downward sloping demand curve, we're down on the bottom of it. We're down on that inelastic part, a point on that bottom inelastic part of the demand curve. If we think about a point at the top in the area where we're in the elastic section of the demand curve, up at the top portion of it, and we, for example, have a point where we say if we're selling it for $800, we're going to say that the units sold is only 200. Therefore, if we sell it for 800, we can only sell 200 units quantity. 800 times 200, we got the 160,000 in terms of revenue. If, however, we increase it from $800 to $1,000 per unit, we're going to say that the quantity goes down from 200 to 100. So now we have the increased price, 1,000 times the units 100. What happens to revenue? 1,000 times 100 is 100,000. So in this case, we're in the elastic area. What happened when we increased price from 800 to 1,000? Revenue went down. It went from 160,000 to 100,000. We can see this graphically if we think about our downward sloping demand curve, and we think about graphing this a bit differently in terms of, let's graph it compared to revenue. Let's now have a graph where we're going to have revenue calculated on the vertical axis. So we have the up and down axis as revenue goes up on the vertical axis from the bottom to top, and then we got from left to right. We're going to talk about quantity. We're going to talk about the price. Sorry, the price from left to right. So as price goes up on the x-axis from left to right, what happens to revenue? Well, obviously, if price is 0, then revenue is going to be 0. It doesn't matter what we're going to sell. We're not going to make any money if we don't sell them for anything. If we say price goes up, for example, to 100, what happens to revenue? If we plot this out, we're going to see revenue goes up to 100,000. And if price goes up to 200, what happens to revenue? It's going to go up to 160,000. So notice that to a certain extent on this side of the graph, as we increase price, total revenue goes up. If we increase it to 600, then in terms of price, then what happens to total revenue, which is going to be quantity times price, it goes up to 180,000. But at some point, we're gonna peak out here. We have a parabola here that's going to have a peak at some point, meaning that as we start increasing price, we're going to go from an area of inelastic area, meaning that's where we're increasing price and revenue goes up, to an elastic area, meaning as we increase price, our total revenue goes down. So, for example, if we increase price all the way up to $1,000, and we would then have revenue of 100,000, so it's now going down. So if we graph it in this format, we can see basically as revenue will increase, we'll hit a peak, and it'll decrease in terms of when it's increasing. That's the inelastic side, and then of course it peaks out, and then it gets to the elastic side. And as we increase price in a good that is elastic, then we actually lose in terms of total revenue. We also have the concept of cross-price elasticity, and that's going to be the idea of substitutes and complements. So when we think of substitutes, we've been talking about substitutes. That means that if we have something else that can replace it. We had a Danish for a donut, so we have to substitute for the donut. If we think about something like a complement, that's going to be something that is related to it, meaning as sales of one goes up, the sales of the other go up. So if you think of donuts and coffee kind of go together. So if donut sales go up, maybe people buy more coffee, or ketchup and mustard maybe go up at the same time. They might be complements to each other. So if we think about the cross-price elasticity, is defined as the percentage change in quantity demanded of one good from the percentage change in price of the other good. So if the price to a substitute of a donut goes up, so the price of the Danish goes up, then the amount of donuts sold will probably go up, because people are going to buy less Danishes and they're going to come buy more donuts. If, on the other hand, the price of the Danish goes down, people are probably going to leave the donut, buy more Danishes, and therefore the quantity of donuts will then go down. If we're talking about complements, then of course the opposite is the case. If the price of mustard goes up, and people always buy mustard and ketchup together, and they say, well, if the price of mustard goes up, then I'm just not going to buy condiments altogether, then as the price of mustard goes up, then the price of both mustard and ketchup, the quantity of both mustard and ketchup would then go down. If the price of mustard goes down, then that could raise the quantity of ketchup that's actually sold, because they're complements to each other. We will now apply this idea of elasticity to what is called income elasticity of demand. So when we are comparing now, instead of changing price, we're changing how demand will change in relation to a change in income. So if our income increases, what's going to be the change in the quantity? So it's going to measure change in quantity demanded from the change in income, and this will give us rise to some new terms, and those new terms being a normal good versus an inferior good. So normally we would think of normal goods, meaning if we got more income, if we got more money, if we had more money to spend, for most normal goods, we would probably buy more of them, assuming what we buy already, we like what we buy, therefore we would buy more if we were able to, being able to by the fact that our increase in income, we have more income in order to buy them. But there are some goods that are what we call inferior goods, in which case, if our income goes up to a certain level, we would actually possibly purchase less of them. And those are going to be goods that are usually like kind of discount goods. If we're talking like fast food or something like that, as our income gets up to a certain level, we may actually buy less of that, of course, and start buying good food. We're going to be dining in nicer restaurants or something like that, and probably having less fast food for the most case. A lot of type of goods are going to be like that. If we buy like the certain brand name, the store brand versus the more higher quality brand, those are going to be types of things in terms of a normal good versus an inferior good. That difference being in the case of us comparing our income again. As our income goes up, what's going to be the behavior of our purchase patterns for certain types of goods. If it's normal, we buy more of that particular type of good. If it's inferior, then as our income goes up, we actually buy less of it. Price elasticity of supply. We've taken a look at price elasticity of demand. Now we're going to continue with price elasticity of supply, which will be the change in the quantity supplied from a percentage change in price. So this is going to be the same concept in that we're going to see how price changes, price is going to change, and we're going to see what the change in the quantity supplied is. So these are going to be the producer half, the producers making the stuff, making the goods, making the quantity. As the price change, how much will they then produce? Now, again, when we think about this, oftentimes it's easy to think that, well, they set the price. If they're the producers, they set the price. But that's not generally the case when we think about the market as a whole. We're saying the market is setting the price. This is what these things can be sold for, and therefore, how many more people are going to enter into the market, how much more production will be if the case that the market price goes up. So remember that any individual is a price taker within the entire market. So when we say price goes up, we're not saying that any individual firm raised their prices. We're saying that basically the market price went up, and then we're trying to see, okay, what will suppliers do in terms of quantity that will be produced? And of course, we would think that the quantity would go up, just considering our upward sloping supply curve. So remember, if we look from left to right, we've got our upward sloping supply curve. General assumption being that if price goes up, then the suppliers are going to supply more quantity. So as price goes up, as suppliers can sell more, they will then increase the quantity that they will sell. Same question when we deal with elasticity then will be, well, how much of a change in price, how much will that affect the output in terms of the suppliers increasing the quantity? That's going to be the question. That's elasticity. So remember the same type of concept with our rubber band. If we put a little pressure on the rubber band and the quantity of output changes a lot, it stretches a lot, well, it's very stretchy then. It's very elastic. So if we put a little bit of price change in there, a little bit of pressure in terms of price on the quantity supplied this time, and the quantity supply changes a lot, it's going to be very elastic then. If we put a little bit of pressure on price, we change price, or if we put a lot of pressure on price, we change a price by a lot, and the quantity only changes by a little bit, then we're going to say that it's going to be inelastic in terms of the production, in terms of the supply. Formula, going to look very familiar. We're going to say it's going to be the change, or the triangle, the delta Q over Q. So it's the change, meaning the last times and this times, the difference between those two divided by the original number. That's going to be the formula over the change in price divided by the original price. So we can also say that as the percentage change in quantity divided by the percentage change in price. That's going to be our formula, same kind of formula we had before. Not exactly the slope of the line, but they are related in some instances. Therefore, you can kind of visualize the line. If we were to graph a line that was going to be inelastic, if you think of an inelastic supply curve, remember the supply curve from left to right, it's going up. So from left to right, it's increasing. If you have one that's more vertical, if it's looking very vertical, then it's going to be more inelastic. So remember, price is on the vertical axis, quantity on the horizontal. If we have a very vertical upward sloping line, then we can have a fairly decent change in price, fairly large change in price, let's say, and we would still have a very small change in terms of quantity because of the angle of that line. And if we have a line that's going to be more flat, it's an upward sloping line, but it's pretty horizontal in this case, then a small change in price will have a larger change in terms of quantity, in terms of the output. So we're talking about the suppliers, how much are they going to produce as the market prices change. What causes the supply to be more elastic or inelastic? We can think about those factors that as price increases, what would make it more likely that then production could increase or decrease? For example, if there's an increase in production with little cost, meaning that if price goes up and we can easily increase production without that much more cost involved. So for example, if there's like low cost in terms of inputs, we can easily buy the more inputs in order to put it into production. So if price goes up, we can put in more inputs and increase the production. If we have interchangeable parts, if it's easy for us to interchange parts in order to increase production, if we can move parts and inputs to different areas in order to increase production, those types of things will make it easier for us as suppliers in order to increase supply as price changes. If, however, it's difficult for us to apply more of those inputs, then it's going to be more difficult for us to increase supplies. For example, if the inputs just aren't really there in the short run, then it's going to be difficult for us to put in the supplies. In the long run, it's more likely that those inputs will be put in place. And that's going to be another factor in terms of just timing. If the price goes up, oftentimes in the short run, many types of industries will not have the ability to increase production. So, for example, if we were making something like paper clips, it would be pretty easy to get the steel, the inputs, to put into the paper clips, and we can increase the production of paper clips fairly easily without much cost in terms of adding the inputs or having a large part of inputs or having to buy a lot more steel in terms of the inputs. On the other hand, if we're making something like cars or something like that, then it's going to be a lot more difficult for us to in the short run, increase the number of cars that we're going to have in the short run. So the quantity is going to be less elastic in that case because it's going to be more difficult for us to apply the resources. However, in the long run, we may then be able to increase the production in the long run. So oftentimes we have this timing difference. In the short run, we may be less responsive to a change in price, meaning we're going to be more inelastic. And in the long run, we're going to be more elastic because we then can take steps in order to accommodate the new price in the long run. There's also going to be a factor if we're a small share of the market for the inputs versus if we're a large share of the entire market for the inputs. For example, if we're talking about the steel again, and we're making paper clips, if we make paper clips and they increase the price for paper clips and we're going to increase quantity for paper clips, well, we can buy more steel to make paper clips and it will be a very small fraction of the entire steel market. But if we make cars and we're trying to increase the input for cars and we're trying to produce more cars, then we're going to need more steel. And the fact that we're going to be producing more cars will affect then the steel market. So the price of the inputs could actually increase as increase the amount of cars that we produce. So then our inputs are going up. That's going to make it more difficult to increase the production, making it more inelastic. We also have the idea of the local change versus a more larger market type of changes. Smaller market changes, more narrow changes being more elastic for the most part. More larger scale changes are going to be more inelastic for the most part. Example, if the price of gas goes up for a particular area, then it is possible for the supply of gas to possibly increase for a particular area, for a particular state. However, if the price of gas overall, and therefore the price of oil overall, increases for a world market, then that's going to be more inelastic. But because in order to increase the supply there, of course, we would need to probably drill for more oil and expand production in some way. That's going to be a longer process, therefore it's going to be more inelastic. So more local markets are more elastic for the most part because we can usually apply resources to the more local market as opposed to the entire market, in which case it's going to be more inelastic because it's more difficult to gather the resources to increase the supply for the entire market, increase quantity supply for the entire market.